Welcome to the DIY Honda Garage channel. The DTC P0107 refers to a fault in the manifold absolute pressure MAP sensor circuit, indicating that the circuit is experiencing low voltage. The MAP sensor plays a critical role in measuring the air pressure within the intake manifold, which is vital for the engine control unit, ECU, to manage fuel injection and ignition timing effectively. By analyzing the pressure data, the ECU can determine the engine's load, thus optimizing performance and emissions. The MAP sensor is typically located on or near the intake manifold itself. If there is low voltage detected on this circuit, the PCM, which is the powertrain control module, may trigger this diagnostic trouble code due to deficiencies in performance. Before tackling the diagnostics, a review of the general troubleshooting methodology helps ensure a stepwise approach to identify and rectify the underlying issues accurately. The error described by DTC P0107 is specifically about a failure within the MAP sensor circuit, causing a low voltage reading. The MAP sensor serves a significant function by measuring the pressure inside the intake manifold, which is crucial data for the engine's fuel management system. It helps the ECU optimize the air-fuel mixture for better combustion and improved overall fuel efficiency. The MAP sensor is typically connected via a 3P connector and mounted on the intake manifold, making it somewhat accessible for diagnostics. When the circuit voltage drops below the expected threshold, the PCM identifies this anomaly and changes its operational parameters, which can lead to poor engine performance and increased emissions. Identifying this issue early is essential for maintaining the vehicle's efficiency and reliability. Several possible causes could lead to this low voltage reading associated with DTC P0107. First, a faulty MAP sensor may not send accurate pressure signals, causing instability in the engine's performance metrics. Second, wiring issues could result from fraying, shorts, or breaks within the wire that connects the MAP sensor to the PCM. Poor connections at either end of the circuit, typically at the MAP sensor and the PCM, can impede the transmission of voltage signals. Environmental factors, such as moisture entering the connectors, could also create issues that mimic sensor failures. Therefore, ensuring that the wiring and connectors are in optimal condition is crucial for resolving this trouble code effectively. When troubleshooting, each of these potential causes should be methodically assessed to pinpoint the issue. The presence of DTC P0107 may present several observable symptoms, primarily related to engine functionality. Drivers might notice a general decrease in engine performance, which could manifest as stalling, lack of acceleration, or a rough idling condition. An increase in exhaust emissions can also occur because the engine may run rich or lean if the ECU is unable to receive accurate data from the MAP sensor. Often, the check engine light on the dashboard will be illuminated, alerting the driver to the need for immediate diagnostic attention. While some drivers may not observe severe symptoms, the underlying issues will affect engine efficiency in the long term, leading to higher fuel consumption and reduced reliability. Addressing these symptoms quickly could prevent more serious issues down the road. The first step in troubleshooting DTC P0107 is to turn the vehicle's ignition to the on mode without starting the engine. This action powers up the electrical systems but maintains them in a non-operational state. Once the vehicle is in this mode, the next step involves checking the MAP sensor voltage using the Honda Diagnostic System, HDS. According to diagnostics, the expected range for the MAP sensor voltage should exceed 0.23 volts. If the reading is equal to or less than this threshold, it indicates that the system may currently function intermittently. The technician should evaluate for poor connections or loose terminals at both the map sensor and the PCM as potential issues. This verification step is crucial for isolating whether the problem lies within the circuit or is a fleeting electrical disturbance. Or the second troubleshooting step. After turning the vehicle to the off or lock position, disconnect the map sensor from its 3P connector. Following this disconnection, the technician should turn the vehicle back to the on mode without starting the engine and recheck the map sensor voltage with the HDS. The expectation at this stage is again that the voltage should be above 0.23 volts. If the voltage is still detected as low, technicians should escalate to the next testing step to evaluate the map sensor itself. This step serves to isolate whether the map sensor has failed, the wiring is damaged, or if the issue lies within the PCM circuitry. Documenting the results of this test is essential for the next course of action. During the third troubleshooting step, the technician will measure the voltage between designated test points within the map sensor 3P connector. With the map sensor disconnected, it is crucial to check between test points 1 and 2 for an approximate voltage of 5.0 volts, which indicates proper supply voltage to the sensor. A reading of about 5.0 volts suggests that the circuit from the PCM to the map sensor is functioning correctly. If this value is not achieved, it is imperative to move forward with diagnosing potential wiring or circuit issues. If this voltage is confirmed, however, it indicates a faulty map sensor. In this case, replacing the map sensor would be the recommended course of action to restore functionality to the vehicle's operational systems. The fourth troubleshooting step involves performing an open wire check on the VCC1 line. Start by transitioning the vehicle to the off or lock state and employing the HDS to jump the SCS line, which indicates an open circuit service condition for more than 1 minute. Disconnect the PCM connector E80P to set up for continuity checks. The technician should then verify continuity between designated test points, specifically from the map sensor 3P connector to the PCM, focusing on the specific pins indicated. If there is continuity, the VCC1 wire is considered intact, and further issues may need to be diagnosed. Conversely, if continuity is absent, it signals that there's an open in the VCC1 wire, necessitating repairs to restore electrical connectivity. In the fifth troubleshooting step, a shorted wire check for the PB line is performed. As with the previous steps, start by ensuring the vehicle is in the off or lock mode and jumping the SCS line with the HDS. After a minute, disconnect the PCM connector E80P for reliability in testing. Continuity needs to be checked between the map sensor 3P connector and the body ground to determine if there is a short circuit present in the PB wire. If continuity is present, it indicates a short has occurred, calling for immediate repairs of the PB wire connecting to the PCM. If no continuity is found, the PB wire integrity is confirmed, and further troubleshooting focusing on the PCM or other components may be in order. To confirm the success of the repairs made in addressing DTC P0107, technicians must conduct a final verification process. This involves running a comprehensive check to ensure that the map sensor and its associated circuitry are functioning properly without any current faults. A road test is strongly recommended, where the vehicle is driven under varied conditions to verify that performance matches expected operational standards. Following the drive, it's important to recheck with the HDS to ensure no new DTCs emerge within the error logs. The goal is to ensure that the vehicle systems are operating optimally, confirming that all fixes have taken effect. This step is crucial to avoid returning the vehicle to the customer with unresolved issues that could manifest later. preventive maintenance plays a critical role in avoiding future occurrences of DTC P0107. Regular inspections of connectors can help ensure that they remain clean and free from corrosion or moisture, both of which can lead to electrical faults over time. Wiring conditions should also be assessed routinely for any signs of wear, crimping, fraying, or electrical shorts that could disrupt function. Conducting routine tests on the MAP sensor can help catch issues before they lead to more significant performance impacts. Maintaining good practices for vehicle upkeep, such as replacing worn parts and utilizing quality materials, further supports the longevity of the MAP sensor and its circuits. Adhering to a structured maintenance schedule lowers the likelihood of encountering errors like P0107 in the future. In conclusion, the DTC P0107 highlights the importance of the MAP sensor's role in the engine's efficiency and responsiveness. This diagnostic trouble code signifies a failure within the MAP sensor circuit, indicating low voltage that can severely impact overall vehicle performance. A structured and methodical troubleshooting approach is essential for effective resolution, beginning from verifying the existence of the code through to resolving all detected issues. Each diagnostic step serves to isolate potential faults, whether they pertain to the sensor, its wiring, or the associated PCM circuitry. By implementing timely maintenance and repair actions, along with preventive strategies, vehicle operators can maintain a high level of performance and reliability, reducing the risk of future occurrences of this error. Please like and subscribe to the channel. See you next time.